Now let's do an ion. Okay, so let's determine the number of valence electrons. So we got N. Let me write this in green. We got N. And N has 5 electrons. We got 3 O's, each with 6 electrons, so 6 times 3 is 18. And then that minus charge tells us that we need to add 1 electron. So 18, so that would be 23, 24 total. Just some really quick and sloppy math there. So I added 1 electron at the end because of that negative charge. Remember that if it was a positive charge, I would subtract 1 electron because electrons are negative. So now let's determine the conductivity. I'm going to take a wild guess and say that would be something like that. And now, connect atoms with single bonds and add lone pairs. Some chemists just draw lines as lone pairs, horizontal lines, and that's completely fine with me. If you're in another chemistry class, your teacher might ask you specifically not to do that. But again, it's just a matter of personal preference. So that's basically what we have to do for that, but let's see if it agrees. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that agrees, but that's not necessarily correct. And here's why. We gotta remember about the formal charge of the nitrogen and talk about why it's wrong to do it this way. So I'm actually going to copy this and paste it into our formal charge lesson. So formal charge is the charge of the individual atoms, and the sum of the formal charges, so this is a fancy symbol that represents sum, formal charge should equal the sum of the net charge of the entire molecule. So let's get this straight. This is NO3 minus, right? So for ions, we draw brackets around them and put the charge on the outside. That's just how we usually do this. So that means the sum of the formal charges in here should equal -1. Let's just see if this is right, though. So there is a really easy method to figure out formal charge. Simply count the number of electrons in the lone pairs around a specific atom, and then count 1 electron for each single bond, and add that to that. And then we subtract that from the number of valence electrons that it should have. So oxygen should have 6 valence electrons, right? Well, we look at this and we think, okay, 1, 2, 3, 4, 5, 6. So that's 6 right there, but then we're adding a 7th right there. So the valence, or the formal charge of that is -1. We know the formal charge of that's -1. And the formal charge of that is -1. So we're already down to a -3 net charge. But now let's take a look at this nitrogen. This, it looks like we even skipped a rule in example 2. There should be a lone pair there, because this used to have only 6 electrons, now we're making it 8. So looking at that, can calculate the formal charge of the nitrogen. So nitrogen should have 5. 1, 2, 3, 4, 5. So the nitrogen is okay. But if we did it this way, again, the net charge would be something like -3. So this is not the proper charge of the nitrate ion. So let's redo this one, keeping formal charge in mind. So I'm just gonna quickly erase everything from this page. Okay, so we got nitrogen, and it's connected to 3 oxygens and 1 lone pair. Okay, and we used to assume that each of these oxygens had 3 lone pairs, but we know from what we just did over here that that's incorrect. So let's try double bonding a few of these and seeing what happens. Let's just double bond one of them. So I think that was supposed to have 24 electrons, right? So let's count them. 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that's 24, but let's make sure the formal charges agree. So this has 1, 2, 3, 4, 5, 6. Formal charge of that oxygen is good. 1, 2, 3, 4, 5, 6, 7. So this has a formal charge of -1. And then this one also has a formal charge of -1. But now let's take a look at the nitrogen. The nitrogen has a formal charge of +1 because we got 1, 2, 3, 4, no lone pairs. So these charges cancel out, and we're left with the formal charge, a -1, and net charge, a -1. So that is the Lewis structure for the nitrate ion.